Welcome back to our next lecture on DSP, Digital Signal Processing. Already you know that myself is Dr. K. MANIKANTA, and assistant professor in the Department of Electronics and Communication Engineering. And today topic is what is DSP, what is the block diagram of digital signal processing, and what are the classifications of the signals and systems. So coming to the course syllabus, already we have discussed the different what are the objectives and what are the outcomes from these five modules. And in that first module is introduction to DSP, introduction to digital signal processing. In that we have different sections and different topics. In that first topic is DSP block diagram and the classification of the signals and systems. Coming to the signal and system, what is a signal and system? Already you know that in SS we already studied it is a prerequisite subject, and there you have studied that signal is a physical quantity which is nothing but which can carry the information from one place to another place, and it can be changed depend upon the independent variables. Depend upon the independent variables, the signals can be classified into one-dimensional, two-dimensional, and three-dimensional. What is one-dimensional, two-dimensional, and three-dimensional? One-dimensional is nothing but which is a signal which can be depend upon only one independent variable like time or any other thing, any other signal quantity. If it is 2D, it will be depend upon two independent variables, and if it is 3D, it will depend upon three independent variables. So, if you coming to the definition of a signal, the basic definition is signal is any physical quantity carrying information and that varies over a time or space. Means it is nothing but depends upon the independent variables. And here the examples have electric voltage, sound, and whatever the sound I am producing, that is also one type of signal, and image brightness. And coming to the system, what is system? System is nothing but whatever the signal I am producing, if I want to transmit from one place to another place that same signal, I have to process that signal. That's the signal I have to process and I have to send to the output. Means whatever the destination, to the transmitter side, to the receiver side. So at that time we need a system to devise a process that takes an input signal and operates on it and then produce the output signal. That is the purpose of a system. And we have different types of systems, amplifiers, filters, and human ear. Human ear also one type of filter, because I can listen and I can transmit my things to the brain, and then I can understand things. So signals have the functions, and they can be denoted by x of t and x of n, where x of t is a continuous and x of n is a discrete representation. Here the small t will be represent the it is a continuous signal, and a small n will represent the it is a discrete signal. And the system has the mechanism that transform them from forming the basic understanding of communication. That is the brief intro about the signals and systems. So coming to our defined digital signal processing and system. Already you have defined the signal and system. What is digital and what is the processing? Also you know, processing is nothing but which is used to process the input signal and will send to the output. Coming to the digital. What is digital? Digital is nothing but a combination of ones and zeros. Ones and zeros. So, the digital signal is a communication. We use discrete signal to represent the data using binary numbers. So, already you have analog signal processings. The analog signal processings have different issues in the analog signal that also we will discuss here. Analog signal processing, that's why you're coming to the digital signal processing. What is digital? The same data, whatever the analog data is there, that will be converted to binary numbers. Binary is nothing but ones and zeros. That will be transmit from the analog signal to the binary signals. And signal is a physical quantity, already you know, processing and system. So whatever the analog signal processor have, that analog signal processor, the analog signals is replaced by the digital signal, where we need a converters to convert the analog to digital, and digital to again analog at the receiver side. So what is the need? What is the need of analog to digital converter? In our universe, every signal should be in every signal is in the form of analog. Every signal is in the form of analog. So we have to connect that analog signal to the digital signal, while the DSP, digital signal processor, whatever the block of the DSP is there, that has to transfer the analog signal to the, means that has to convert the analog signal to the digital signal before giving to the DSP. So the analog to digital converters are mandatory. Okay, then after that, the digital processor DSP will give the what? Digital signal only. That digital signal has to change again to the analog signal to understand by the human beings or any receiver. So that's why again you need a D to A converters. So this is about the digital signal processing brief. Then coming to the analog signal and digital signal, what is the difference? The analog signal were used to many systems to produce the signals to carry the information. Whatever the digital signals also same, they carry the information. These signals are continuous in both values and times. Suppose I have a signal in the form of this, like this is an amplitude and this is an time. I have a signal like this, one triangle signal. So if you see here, if it is 0 to 1 interval and 2 interval, if you see 0 to 1, you have infinite number of values, means the time at the different values of time also the signal is producing the signal is producing the amplitude value, nothing but it is continuous, and this type of signals are analog signals. Coming to the digital signal, what is the digital signal? Already in the next slides we will see whatever the examples are. Coming to the digital signal, the same signal will if you want to produce in the digital at 0 to, in the interval of 1, 0.1, 0.2 and 0.3 I am taking. At that time only it is taking the signal type, means only the discrete values, and the digital discrete values it is showing the amplitude value. These are called stems in the DSP. Means digital signal law, digital signal we will call the stems. These are the stems. Okay, see here, you can check here, analog versus digital. The analog signal will be continuous and every time of the interval, means till here, and if you see it will be defined at certain values. This is the digital signal, and this will be, this red color will be called as stems. These are the continuous, this is discrete signal. These are the analog signal. Digital signals are nothing but discrete signals. This is the block diagram of a digital signal processing system. If you see here, I have told already, before giving to the digital signal processor, the analog input signal will be given to the A to D converter. Means what? Analog to digital converters, which is used to analog signal will changes to the digital signal, and after that it will be given to the digital signal processor. This is a digital input here, it will produce a digital input, and after that it will goes to the digital signal processor, and after the signal processor, already you know that signal processor which is used to process the signal, means it will strengthen the signal, and it can add the carrier signal. You have different modulation techniques for that, already you have studied in analog communication. That will be comes under these processing systems, and it will give the, and again, digital output signal. Here the digital output signal. So you can we need only analog output signal. So again we need a digital to analog converters here. Digital to analog converters. This will be transmitted to the analog output, and this will be changes to the analog output. In detail, you can see here. This is microphone. I am giving a microphone producing a signal like this, and then signal conditioner I used to strengthen the signal. So, and I have after that an anti-aliasing filter to remove the noise, and then it will convert it to now analog to digital converter. Now it is changed to the binary information, means digital information, and this is given to the processor. And after processor, the digital input, digital output is given by the processor, and this is again given to the D to A converter. Again, it will produce a analog output. This is the smooth and the filtering to produce a good output like this. This is the detailed block diagram of a digital signal processor. So we have the digital signal processing, have the advantages and disadvantages also. What are the disadvantages means? Because why you have to study before advantages, why you have to study the disadvantage means, if you know the disadvantage only, you can research what is the problem in that particular topic. So coming to the applications, here I didn't mention the disadvantages. What are the disadvantages of a DSP? The main disadvantages of a DSP is it needs extra equipment. It needs extra equipments. What's the extra equipment? If you see in the previous slide, it needs A to D converters and D to A converters. Means these are the extra equipments compared to the what analog signal processor. Compared to the analog signal processor, here the only signal processor, instead of digital, we will have analog signal processor. But now we need a digital signal processor. Instead of digital signal processor, if you want to use the digital signal processor, before that you have to use the A to D converter, and after that you have to use D to A converter. So that is the problem. So coming to the digital signal processing disadvantage, the major disadvantage is needs an extra equipments like a to D and D to A converters. And coming to the advantages, due to this, noise is easy to control after initialization of quantization. Means convert after compared to the noise control in the analog signal, the digital signal is very easy due to quantization because it will be defined at a particular values only. So after quantization means it has to convert it to the digital signal. It is easy to control the noise, and highly linear, complex algorithms fit into a single chip. Because of digitalness, you can use here digital chips. And communication systems, what are the application? Consumer electronics, music, medical, and the different digital signal processor applications are there. Next, coming to the classification of signals, what are the different classifications you have in the signals? Means how the signals have different types. Means now I am producing an analog signal which is nothing but a sound, and voltage signal is there, and then you can tell a current signal, pressure signal, temperature variation signal, and we have different types of signals. According to the type of the signal, the classifications will be done in majorly these ways. First one is continuous and discrete time signals. Already we studied previously, we've seen that continuous time signals and discrete time signals. With respect to time, the signal will be produced every time value, the output will be produced as with respect to time, that is at the particular time that the signal will be produced, that will be the discrete time signals. And another one is the periodic signal and aperiodic signal. Means the signal will be repeated at the same interval. Suppose I have a signal in the form of 0 to pi. Means this is a sinusoidal signal. After pi, again it is producing the same pulse at the 2 pi. Means pi to 2 pi. Means repeating a signal at the particular time of period, it's nothing but a periodic signal. If it is not repeating after this, if it is produces, if it is produces like this, after this periodic signal, the signal will be varied. Means it is not a periodic signal, it is an aperiodic signal. Coming to the even and odd signal, it is nothing but even signal is nothing but a symmetric signal. You can also call it a symmetric signal. That it can be represented as x of minus n equals to x of n. For the negative values of the n signal also, that will not vary. Odd signal means it will vary after the deterministic signal and random signal. What is deterministic signal? The deterministic signal and random signal, it is also called as a non-deterministic signal. What is deterministic? In the name only you can say the deterministic means it can be determined by the any mathematical notation, then it is called as a deterministic signal. If you give sinusoidal wave, what is the x of t equals to sin t? Or if it is discrete, x of n equals to sin n, means we are representing the signal in the form of a formula or any mathematical notation. If it is not represented by the mathematical notation, suppose I have a Gaussian noise like this. So this is the signal, but you can't predict and you cannot write the formula for that. That type of signals are the random signals and non-deterministic signal. Energy and power signal. Depend upon the energy and power of a signal, the signal can be tell that it is an energy signal and it is a power signal. Other you can also call as either energy nor power signals. We will see what are the different examples for these classifications of these signals. Coming to the continuous time signal, it is defined at every instant of time. Whatever the earlier I said, it is defined every of time, and the amplitude varies continuously with time, also known as the analog signal. Example, speech and atmospheric pressure, and then atmospheric temperature. These are the examples. This is a sinusoidal wave, and this is a cosine wave, and you have the distance, time, and sine wave. And coming to the discrete signal, it will produce at that particular value of time, and you have mathematical representation like this, and where n is the integer, n is the constant, and t is the sampling period, and these are the signals which produces due to the sampling. If you see here, it will representing at particular values. These will be called as stems. And coming to the periodic signal, I already told that at every interval here from here to here one pulse is completed, one cycle, and after that again another cycle is came with the same amplitude and frequency at time. So that type of signals are periodic signal, and is mathematically represented as x of t equals to x of t plus t, which will be the t is nothing but a time period. At which time period the signal will be repeating, that time is nothing but time period. And discrete time signal is said to be a x of n plus n. Instead of capital T, here we will represent with n to know it is a discrete time. And a periodic signal is coming to the continuous time signal is a periodic if x of t not equal to x of t plus t. In the same way, x of n is not equal to x of, means x of n is equals to x of n plus n, then it is said to be a periodic. And if it is x of n not equals to x of n plus n, it is a aperiodic signal. Okay, these are the example for the aperiodic, means it is not repeating till here to one signal is there, again here to here another signal is there. At every interval of time it is changing the own signal because it is an aperiodic signal. Coming to the periodic signal, if you see here, from here to here same, and again here to here same, again here to here same, again it will produce the pulses same like as the previous one, means it will be repeating after every time at some time of interval. That is nothing but a periodic signal. Whatever the repeating period is there, that will be called as a fundamental period of the signal. Fundamental period of the signal, it is the smaller positive value, and it can be represented by 2 pi m into omega naught. And even and odd signal, I have already told that x of minus n equals to n, and x of minus n equals to minus x of n. So x of n and x of minus x of n, means for negative values of signal also it will produce a positive values, and for negative values it will produce the negative values. Then it is said to be a odd signal, and it is said to be a even signal. Okay, so this is the basic thing. And if you see here, you have also called as even signal is also called as symmetric signal, and odd signal is also called as a asymmetric, anti-symmetric or asymmetrical signal. See here, because if you see here, from the period of 0 to minus t by 2 and 0 to t by 2, the signal is same, means symmetric. If you, what is symmetric? If you half of the signal will be taken here, so the same portion will be reflected in the outer portion, other portion also. That is, if you see here, it is not symmetrical. The shape here to here is different, and here to here is different. These are the asymmetric signals or odd signals. It cannot be repeated. It is a symmetrical signal. And next I have told that deterministic signals and random signals. A signal whose nature can be determined is known as a deterministic signal. Means you can predict by seeing that. We can say that it is a sinusoidal signal, and it is represented by sin t or sin n. A signal whose nature can't be determined is known as a non-deterministic signal. It can't be predicted. It is also known as a stochastical signal, and it is also non-deterministic signal. They can't be predicted. Example, if you see here, it is a square signal with the some time period. If you see here, it is also a time period and all the things, but you can't write a formula for this. Yes or no? It is a noise. This type of signals called random signals. And these are the signals which are nothing but what? Deterministic signals. And you have different sinusoidal and cosine wave, and you have different type of system, triangular wave, anything will be which can be right in the formula. Then those are will be called as a deterministic signal, which can't be predicted by the formula or anything. It can be called as a non-deterministic or random signals. And the last one is the energy and power signal. What is a signal is said to be an energy signal, and what is a signal is said to be a power signal. The energy of a signal lies between 0 to infinity, then, and power should be the average power is equals to 0. Average power is equals to 0. Then it is said to be a what signal? Energy signal. Means you can say that energy signal doesn't have power, means energy signal has zero average power. In the bits it will ask in the competitive exam also, may they ask. So what is the energy, what is the power of an energy signal? Like it will give zero, infinity, and sorry, infinity, zero, minus infinity, and plus or minus infinity, like that they will give. At that time you have to choose zero, because the average power of a energy signal is zero. And coming to the signal is a power signal. The signal will be the power signal, the quantity value of power between 0 to infinity, 0 to infinity, and E is infinity. Remember, for the power signal, energy is infinity, but for the energy signal, the power is zero. That is the thing. And how to calculate this energy and power of a signal? For that we have formula. For calculating the energy signal, E equals to limit n tends to infinity summation n equals to minus 2n mod of x n whole square. For all these for all these signals and the types of signals, we will see the what examples also. And coming to the power, limit n tends to infinity 1 by 2n plus 1 summation n minus n to n mod x of n, where n is the sample and x of n is the nothing but signal. Coming to the classification of discrete time systems and systems, we have different classifications: static, dynamic, and causal and non-causal, linear and non-linear systems, time variant and time invariant systems, stable and unstable systems, invertible and non-invertible, FIR and IR systems. These are the different systems we have in the discrete time system, and also in the continuous also. Continuous system also the same thing is there. The like as discrete time systems, continuous time signals are also same types. Here if you see here, this is a discrete time system and having an x of an input and it is producing y of an output. Depend upon the type of input and the same output will be produced. And the system here, the whatever the output producing by the system, that system types have different types: static and dynamic system, causal and non-causal system, linear and non-linear, time invariant and time variant, and stable and unstable, invertible and invertible, FIR and IR. What is FIR and IR? And a finite impulse response and infinite impulse response. Like that you have. Okay. And this classification will be seen in the next class, and we will see the whatever the different types of systems and what are the use of that system. And thank you.